common factors when you multiply and divide fractions. For instance, with the second problem here, we have 3/5 times 1/9. It's my hope that you notice that 3 and 9 actually do share a common factor. The greatest common factor between 3 and 9 is 3. So you just ask yourself, how many times does 3 go into 3 right there? And that's just 1 time. And then how many times does 3 go into 9 right there? That's 3 times. So you can reduce out that factor of 3. It'll make it a little bit easier for you. Now, not really drastically easier with this problem because the numbers are easy. But if the numbers are large and you don't have a calculator, it can be really, really helpful. So really, you just multiply at that point straight across. We take 1 times 1, that's 1. 5 times 3, that's 15. So 1/15 is your answer there. What's up? Turn it into a mixed number? Great question, Danielle. It didn't come up in my last period, but it did come up in my 4th period today. The question was, do you have to simplify or turn 13/12 into a mixed number? If we are reminded about what we're doing in this chapter, we're talking about how fractions are going to be exponents. And those fractional exponents are actually radicals in disguise. So I have to ask you, within that context, what's more helpful? 13/12 or 1 1/12? 13/12. So I would leave it like that, yeah. Make sense? Okay. And then the last problem, again, I used that trick where I could cross-cancel a common factor. Do you see you have 7 and 49? 7 and 49 they share a common factor of 7. 7 goes into 7 1 time. 7 goes into 7. 7 goes into 49 7 times. So you do 2 times 7, you get your 14. 1 times 1 on the bottom is 1. So you didn't have to reduce the 98 over the 7 at the very end. It saves you a second. So it's a little bit of a shortcut that will help you out if you could grab onto it. Okay, questions about those 4? Okay, and then I just wanted to make sure that you had your answers correct to the independent practice conclusion questions from the end of our time together yesterday. I saw some of you still needed those answers there. Part D, answers will vary. The answer's not AWV. It's not bad to talk about it right now, though. Although I know Ms. Goldstein talked about it a little bit when she went over your homework. Do you remember from yesterday's lesson when do you need the plus or minus and when you don't? Right. Even power in the original problem or as you work through an even index? Yeah. Okay, and then your little geometry application problem. Are there any questions about this one? I put a little note to you. I have a tickle in my throat, I'm sorry. If you have 2 pi on the bottom of your fraction, you go to divide. Make sure you put parentheses around that. As I've said many times in this class, your calculator is stupid. It would take 25 and cut it in half first. It's 12 and a half. And then it would multiply it by pi and then square root it. That's not what we're asked for here. We're supposed to take 25 and divide it by 6.28. That's a different value. So you kind of want to keep that in mind. Make sure you quantify very carefully when there's fractions in your problem. Go ahead, Danielle. Which way did you do it? Divided by, yeah, that's fine. Any other questions about that one? Because as you've seen, some of you got that far in your homework. You saw that there are problems like that on the little worksheets that you grabbed. Was that yesterday? So this might help you through that a little bit. Okay, so today's lesson is very much lather, rinse, repeat on properties of exponents. You had an assignment. It was the very first assignment for the semester. The title of the worksheet was More Properties of Exponents. And if you'll recall, I think you got your little homework quiz on that assignment back yesterday. You did a really nice job when the exponents were whole numbers. Well, today it's the same exact list of properties. That's not different, except this time around are exponents will be fractions. So we have to do those exact same properties with fractions. So now you can see why I had you do those 4 problems for your warm-up today. Review those operations with fractions a little bit. So we do have a list. And I'll screen shade and walk you through them a little bit. You already have this list. If photocopied on a graphic organizer from 5.1, you have a nice gold sheet. It's the exact same properties, just to let you know. Our first property on that paper was the product property. You're allowed to use it to simplify an expression where there's a product of like bases represented. So if you have like a to the m times a to the nth, that's the same thing as a to the m plus n. So I gave you an example there. If you have 4 to the 1/2 times 4 to the 3/2, you just add the 1/2 plus 3/2. That's 4 over 2. 4 over 2 is just 2. And then 4 squared is 16. The next one we have is a power property. Ooh, that's a lot of information. Let me not overwhelm you there. We do have it for 3 cases. 3 cases. We deliberately exclude 2 cases, and that's the little fill in the blank that you have there. We're allowed to use this. I often call it the distributive property for exponents. You're allowed to use this property as long as there's no what or what in your parentheses. We talked about it, especially up here on the marker board. Megan. Very good. Addition or subtraction. Nice job. So that's what goes in your fill in the blank there. You could have a plus or a minus. We're allowed to use this distributive property for exponents as long as there's no plus or minus in the parentheses. So what if there is a plus or a minus? Do you remember what you have to do? Like if you have x minus 1 quantity squared, you're not allowed to distribute that squared in. What do you do instead, Alec? I think you're thinking about rationalizing and you're giving me what's called the conjugate. Yeah, that's when we divide radicals. So like up here, this student, we said yesterday, accidentally distributed the exponent into the parentheses, but there was a minus, and they weren't allowed to do that. So my question to you folks is, what would you have to do instead? Gio? Yes, I was thinking more along the lines of expanding it. What would you have to do instead? If we were trying to isolate the x. FOIL, yes, that was the word I was looking for. FOIL, yeah, okay. Okay, so if we have a to the m raised to the nth power, that's the same thing as a to the m times n. So you'll see here I took 5/2 and multiplied it by 2 over 1. When you multiply fractions, you just multiply straight across. So 5 times 2 is 10. 2 times 1 is 2. 10 divided by 2 is 5. So we get 2 to the 5th, which is 32. Rolling down here, you're allowed to distribute your exponent into that quantity there because there's no plus or minus. So our example kind of looks like this. You have 16 times 4 to the 1/2. You could multiply the 16 times the 4 first, but I wanted to show you the power property for exponents. So I would do 16 to the 1/2 times 4 to the 1/2. That's the same thing as taking the square root of 16 times the square root of 4. Square root of 16 is 4. Square root of 4 is 2. And then 4 times 2 is 8. And that's just one way to do that problem. There's usually more than one way. Makes this section tricky to teach and fun at the same time. It's never the same thing twice. Okay, then we do have that power property for exponents when there's a quotient. So our, for instance, here is if you have 27 over 8 and you raise that to the 1/3 power, that's like taking 27 to the 1/3 over 8 to the 1/3, so you get 3 over 2. How did I get 3 over 2? Anthony? Yeah. Yeah, so if you raise something to the 1/3 power, that's the same as cube rooting. Is that what you were going to say, Alec? Good man. Okay. And then we have our quotient property. Allows us to subtract our exponents. So if you have 3 to the 5/2 over 3 to the 1/2, 5/2 minus 1/2, That's 4 over 2. So you see I have 3 squared there, and then that's 9. This is another one of those lessons where, oh my goodness, if you don't understand what you're writing, stop writing. Like if you don't know where like 5/2 came from, or like why are we subtracting, you should totally ask. Any symbol, if you don't know where it comes from, you gotta ask. And I will answer. Look, I even answered why do we multiply by the reciprocal in my last class. Yeah. No. This rule only applies, it's like the product property. You have to have like bases. So, yeah, like if this 3 down here were a 2, can't do it. Well, you could always turn it into, like if this were a 2 down here, this would be the square root of 2, and then rationalize. So there's always something that can be done. Play around with it a little bit. Any questions on the quotient property for exponents? Okay. And then the last 2 you're super familiar with. We have our upstairs downstairs rule, or our negative exponent rule. If you have 25 and you raise it to the negative 1/2 power, that's the same thing as doing 1 over 25 to the 1/2, which is the same thing as just taking the square root of 25. So you get a 5th. And then I really like the last example. You have 3 to the 1/2 over 3 to the 1/2. Well, you folks are so good at that. Like, you know 7 over 7 is 1. 5 over 5 is 1. I said in my last period class, Pez over Pez is 1. Like, it's just how it is, you know? Well, 3 to the 1/2 over 3 to the 1/2 is also 1. And now you get to see how the zero exponent property works. If you subtract a 1/2 minus a 1/2 there, you get 0. And for that reason, we could say 3 to the 0th power is 1. It's kind of cool. If you get 7 pieces of cake and there were only 7 pieces to begin with, you ate 1 whole cake. If you get 3.5 pieces of cake and there were only 3 to the 1/2 pieces of cake, I should say. It's a weird number, square root of 3 pieces of cake. Very exact little party. But, you know, you get 3 to the 1/2 and pieces of cake, and there were only 3 to the 1/2 pieces of cake to begin with. You ate the whole thing. It's like a little over 1.5 pieces. Lame party. 1.5 pieces of cake. Not much of a party. All right. Any questions about our properties there? No? Okay, so if you turn the page, you get a chance to practice these properties on your own. Okay, so there's your answers to the first 2. Take a second and check with letters. So you guys did a nice job. Just have a little bit more to go, and then it is the weekend. Yeah, woohoo! So you might be saying, why do we have these properties? It just feels like a bunch of hullabaloo to get another number. Like, what do we need this for? All right, so true story. Oh. So before we digress too far about that, so we have the square root of x to the 5th times the cube root of x. I'm hoping that this problem alone helps you understand why these properties can be so useful. I have a question for you, and my question is this. Are you allowed to just use the product property and multiply those 2 things together? No, why not? Very smart. Kristen. They have different indices. Yes, they do. I mess that up all the time, too. Yeah, so we can't just jump right on in and use our product property for radicals. You're not allowed to do that when the indices are different. So with that, we can actually rewrite these problems here with rational exponents and then use our properties to simplify. So it's super nice. For instance, this would be x to the 5/2. And the second factor would turn into x to the 1/3, based on our ER rule from a couple days ago. Questions about that step? So the steps for this, very much, I turn them into rational exponents and I use my properties. That's the 2-step approach to when you see variables in this chunk. So you turn it into a rational exponent if needed, and then you simplify with your properties. So now I have like bases multiplied together. Can anybody tell me what I'm allowed to do with the 5 over 2 and the 1/3? Noah. You do. But you need a common denominator, well said. The common denominator would be 6. So if I turn 5 over 2 into a denominator that has 6, I'm multiplying that denominator by 3, which means I need to multiply the numerator by 3. And then 1/3 with a denominator of 6 is just 2/6. So you get 17 over 6. Check out the answer, though, or the directions, I should say. Oh, we have to leave it as a simplified radical. Oh, man. So we have to do our ER rule to actually rewrite this as the 6th root of x to the 17th. Is that done? The 6th root of x to the 17th? No. What do I do to simplify that now? Alec? Yeah, very good. So 17 divided by 6, or 6 goes into 17 how many times? Yep. And? Yes. So that's the answer as a simplified radical. Part B is a little easier because step 1 is done for us. The exponents are already rational. So now I can just use my associative property of multiplication, and I can just rearrange. So I'm going to multiply the -5 times the 3 together, and then the x to the 5/3 times x to the -3/4. -5 and 3 as a product evaluates to -15. And then I add my exponents once again. And I do need you to finish these notes for when you come back in on Tuesday. They'll be on Blackboard for you. Yeah.